Hello friends, welcome to SSP Math. Today we are going to start new topic. The topic is linear independence and dependence of vectors. In last video we already learned linear combination and linear spanning. Now what is meant by linear independence and when given vectors are linearly dependent. So first one is linearly dependence. Linearly dependence means the vectors v1, v2 up to so on vn. These are the elements of V. So the vector elements of the vector space V. So the vector v1, v2 up to so on vn are said to be linearly dependent if there exists a scalar c1, c2 up to so on cn, not all zeros. This is very important. Not all zeros, such that c1 v1 plus c2 v2 plus so on plus cn vn equal to 0. Means this linear combination is equal to 0, but the values of scalar c1 to cn not all zeros, then we can say that given vectors v1 to vn are linearly dependent. If n vectors are there, then there exist n scalars. Okay, what is mean by linearly independence? Linearly independence means same definition is same. The vectors v1 to vn are said to be linearly independent if there exists a scalar c1 to cn all are 0 such that c1 v1 plus c2 v2 plus so on plus cn vn equal to 0. Means इस पर प्रॉब्लम होता है एग्जामाइन वेदर द फॉलोइंग वेक्टर्स आर linearly dependent or independent. If dependent, then find relation. Means suppose if given vectors are linearly dependent, then there exists some relations. We have to find that relation. If vectors are linearly independent, then no relation. So one note is given here. Two vectors u and v are dependent if and only if one is multiple of the other. Means in short, suppose first vector given a 1 1 1 and second vector given a 2 2 2. So first and second are multiples of each other. 2 2 2 is multiple of 1 1 1. Okay, so we can say that two vectors are linearly dependent directly using this note. Okay, now we will take some problems on linearly dependent and independent. So first problem is determine whether the following vectors are linearly dependent or independent. If dependent, find the relation. So first problem is 1 2 0 0 1 minus 1 1 1 2. So here we have to given that three vectors. Suppose our first vector is say v1 is equal to 1 2 0. Second vector is say v2, that is 0 1 minus 1, and third vector is v3, that is 1 1 2. So we have to check that these three vectors are linearly independent or dependent. Now three vectors given, so there exist three scalars c1 c2 c3 such that the c1 v1 plus c2 v2 plus c3 v3 equal to 0. So what is the definition of linearly dependent and independent? If we get here c1 c2 c3 are all 0, then we can say that v1 v2 v3 are linearly independent. If c1 c2 c3 is not equal to 0, then linearly dependent. So we have to find here c1 c2 c3. So put given vectors here, c1 into v1 a 1 2 0 plus c2 into v2 a 0 1 minus 1 plus c3 into v3 is 1 1 2 equal to 0, means 0 vector, that is 0 0 0. So multiply c1 c2 c3 inside these vectors or inside this matrices and equate with RHS. Then we will get first equation c1 into 1, that is c1, plus 0 c2 plus c3 equal to 0. Okay, then second equation is 2c1 plus this 1 into c2, that is c2, plus 1 into c3 is c3 equal to 0. Third equation is 0 c1 minus 1 into c2 minus c2 plus 2 c3 equal to 0. Okay, now we have to write, or we have to find here c1 c2 c3. So this is the homogeneous system. Okay, if we write this system in matrix form, then that matrix is 1 0 1 coefficient matrix, 2 1 1 and 0 minus 1 2 into c1 c2 c3 is equal to 0 0 0. So this is the homogeneous system. Take matrix A. Matrix A is coefficient matrix here 1 0 1 2 1 1 and 0 minus 1 2. Okay, and how we solve this homogeneous system? First write this system in matrix form, take matrix A and reduce to canonical form. So here already 0 present is, so we have to use here only one operation. We want this to 0, so use R2 minus 2 times R1. So if you use R2 minus 2 times R1, then we will get 1 0 1. 2 minus 2 is 0, 1 minus 0 is 1, and this 1 minus 1 is 0, 0 minus 1 2. Okay, then use, we want here 0, then use next operation is R3 plus R2, means R3 becomes here R3 plus R2, so 1 0 1, 0 1 0, 0 minus 1 plus 1 0, and 2 plus 0 is 2. So rank of A is equal to 3, equal to number of unknowns. So this system has unique solution, and we know that unique solution is a zero solution. Or using this here, if we write augmented matrix, the augmented matrix में यहाँ पर 0 0 0 आता है because the matrix is 0. So using this we can write system of linear equations again, C1 plus 0 C2 plus C3 equal to 0 from this, and from this we can write here C2 equal to 0. Okay, and from this 2c3 equal to 0, 2c3 equal to 0, then c3 equal to 0, c3 equal to 0, c2 equal to 0, put here, then we get c1 equal to 0, and therefore c1 equal to c2 equal to c3 equal to 0. So okay, so therefore given vectors are v1 v2 and v3 are linearly independent. If linearly independent, then no relation. If dependent, then there exists relation. Here we get all the values of c1 c2 are 0, and therefore given vectors are linearly independent, so there exists no relation between them. So next problem is same. This check whether this set is linearly dependent or independent. You solve this 1 2 3 minus 2 0 1 4 minus 4 minus 9. Then we will solve third problem here. We have to check this set is linearly dependent or independent. 1 1 1, 2 2 2 and 0 1 5. Okay, so three vectors given again same as last problem, that is v1 is equal to 1 1 1, v2 is equal to 2 2 2, and v3 is equal to 0 1 5. So there exist three scalars c1 c2 c3 such that c1 v1 plus c2 v2 plus c3 v3 equal to 0. So put here v1, that is 1 1 1, plus c2 into v2, v2 is 2 2 2, plus c3 into v3, v3 is 0 1 5 equal to 0 vector given है, that is 0 0 0. Now if you multiply c1 c2 c3 inside this matrices and by equality of matrices, then we will get first equation c1 plus 2c2 plus 0 c3 equal to 0. Second equation is 1 into c1, that is c1 plus 2c2 plus c3 equal to 0. Third equation is 1 into c1 is c1 plus 2c2 plus 5c3 equal to 0. So this is the homogeneous system, and from this homogeneous system we have to find c1 c2 c3. So we have to find solution of this homogeneous system, and how we solve this system using matrix method. So try to write in matrix form. First row is 1 2 0, second row is 1 2 1, third row is 1 2 5 into c1 c2 c3 equal to 0 0 0. So we want here c1 c2 c3, consider matrix A and reduce to canonical form, or consider AB matrix because B matrix is 0 here. So 1 2 0, 1 2 1, 1 2 5. Okay, now we have to make this element 0 and this element 0. For that we have to use operation here r2 minus r1, r3 minus r1. So if you use this operation, then this becomes 1 2 0, 1 minus 1 is 0, 2 minus 2 is 0 1, 1 minus 1 is 0, 2 minus 2 0 5. Okay, and last operation we have to use here 5a and here 1a. So these are the multiples. So if we use here operation r3 minus 5 times r2, then we will get 1 2 0 0 0 1 and here 0 0 0. Okay, so 1 2 0 0 0 1 and 0 0 0. So here rank of A equal to 2, number of unknowns are 3. Okay, so rank of A is less than number of unknown, and therefore the system has a non-zero solution. Non-zero solution means given vectors are linearly dependent. So if given vectors are linearly dependent, then there exist relations. So for that relation we have to find C1, C2, C3. So using this matrix we can write first equation here. This is equation 1 say, and first equation is here C1 plus 2C2 equal to 0, and second equation is C3 equal to 0. So first equation is C1 plus 2C2 equal to 0, and second equation is C3 equal to 0. C1 plus 2 C2 na? Yes, and second is C3 equal to 0. देखो अब C3 equal to 0 आया, but first equation में C1 plus 2 C2 equal to 0 है. One equation 2 unknown है. So if we assume here suppose C2 is equal to K, mistake here, C2 is equal to K, then we get C1 is equal to minus 2K. Okay, and therefore here only C3 equal to 0, C1 and C2 is not equal to 0. C1 is not equal to C2 is not equal to 0, means when given vectors are linearly dependent, if C1, C2, C3 linearly independent, if C1, C2, C3 are all zeros, here two constants are not equal to 0 and one is 0, and therefore we can say that V1, V2, V3 are linearly dependent. If given vectors are linearly dependent, then we have to find a relation between them. So how we find relation between them? Put C1, C2, C3 in equation 1. अब equation 1 क्या था हमारा? C1 V1 plus C2 V2 plus C3 V3 equal to 0. This is our equation 1. In this equation, if we put the values of C1, C2, C3 here, so what is C1? C1 is minus 2K V1 plus C2 is K V2 and plus C3 is 0 equal to 0. So if we divide throughout by K, then we get minus 2 V1 plus V2 equal to 0, means V2 is equal to 2 V1. So only V1 and V2 are dependent vector here, V3 is independent vector. Okay, so next problem, same problem, you try this, that is fourth, you try this set, that is 1 3 2, then 1 minus 7 minus 8 and 2 1 minus 1. You try at home this, check whether these vectors are linearly dependent or independent. If dependent, then find relation. So I think these are the sufficient problems for linearly dependent and independent. Now you can solve any problems. You start, suppose 3 vectors given, then there exist 3 scalars. If 4 vectors are there, then take 4 scalar. 5 vectors are there, then take 5 scalars and try to find that values of that scalars. If we get all scalars 0, then we can say that given vectors are linearly independent. If not equal to 0, then linearly dependent. If dependent, then there exists relation, so we can find that relation. Okay, in next video we will start basis and dimension of vector space. Thank you.